Hi everyone, I can't wait for today's experiment, but we can't do science in these clothes. Let's get ready. I'm so excited because it's Christmas Eve and today we are going to make a Santa snow globe. Ho, ho, ho! But it's dangerous, so you need an adult, and I'm going to be wearing goggles and gloves. Come on, Dad, let's do this.
All right, Lana, what a great idea for Christmas. Do our pH testing again, get our indicators. This time we'll cheat, we'll use paper with the indicator. That's going to show you how dangerous these chemicals are. But what's funny is that people eat these chemicals. This one, sodium benzoate, in tiny amounts is added to soft drink as a preservative. This one, citric acid, is found in fruits. But when mixed, we're going to get what's called a double displacement reaction. Sorry to be technical, but what it means is we're going to use this acid to turn this salt into an acid, and then it's going to act pretty funny in water, particularly if we change the temperatures. So we're going to deal with some electricity and heat and dangerous chemicals. Definitely shouldn't do this on your own. Let's get started. Lana, add the sodium benzoate. So that's 2 heaped teaspoons.
Here we are using a magnetic stirrer. And this probe is taking the temperature. We are using a scientific hot plate to do this. This all helps dissolve the sodium benzoate.
All right, there's our first beaker. That's the sodium benzoate solution dissolved in about 250 mils of water. Now I'm going to make a second beaker. So I'm going to get this one nice and warm, quite hot in fact. I'm going to stir it. Let's add the acid.
Now we are going to dissolve 1 big teaspoon of citric acid into another beaker.
All right, here's our first solution, the sodium benzoate preservative. And it's a salt that we're going to now turn into an acid. So we'll make sure this stirring is not too fast. We don't have to spit on us. We're wearing goggles anyways and lab coat, right? Let's tip in the citric acid. Be careful, it's very hot. So nothing has happened yet, which is a good indication that the solution's quite warm. We don't need to get it any hotter then. So 70 degrees probably would have been enough.
We are making benzoic acid. Now we are going to let it cool down. It smells, so make sure there's lots of ventilation so you can breathe. Now I'm going to use my universal indicator paper to test my pH.
Can you hold the paper for me, Lana?
Yep.
So here is our citric acid. What color is it turning?
Red.
Let's get it nice and wet. There's not much left in here. So how do we know that's acid? Can you show me the colors? What color does that match up to?
I think it matches up to 1.
Oh, that's very acidic, which is good. Now let's just see if our solution that we've created is the same. Because we were trying to create an acid, right? This is interesting. Get the color now. What color is that?
I think it's 5.
Wow, so the citric acid loses its acidity when we mix it with the sodium benzoate. This is still an acidic solution, so let's tip it in. We're going to use a bowl to catch any mess.
Ho, ho, ho! Here comes Santa! Oh no, his arms are too big, so we have to break them off. Now leave the jar to cool, can't wait for it to snow. Wow, here it is, guys. Now watch me make my snow globe snow. Santa's asleep right now, but on Christmas Day he'll wake up. It snows because the benzoic acid crystallizes when the water cools down. Ho, ho, ho! I can't wait for Santa to see his present. Merry Christmas, everyone! I hope you liked my experiment, guys. Please subscribe and give me a bunch of thumbs up. Love, Lana Banana Science!